Okay, the next section is going to deal with two special right triangles that come up quite frequently, and the patterns that exist between their sides. More specifically, the ratio that always exists between their sides. Like we said earlier, the angle measurements in a right triangle are what determine the ratio between the different sides. Because if I have two right triangles that are similar, so I'll just copy this one. If I've got two that are similar, okay, and this is also right, okay, I could say that A over D, so the ratio of the two short sides here, would be the same as if I put C over F or B over E. Okay, another way I could write this is I could switch the means so that A over C is the same as D over F, which means the ratio between the short side and the hypotenuse of any right triangle that has 30, 60, and 90 degrees in it is the same amount. Okay, so now we're going to look at what those ratios are. So anytime you have a right triangle whose angles are 30, 60, and 90 degrees, the length of the short side is going to be your basis for the lengths of the other sides. Whatever this side is, I'm going to double it to get the hypotenuse, and I'm going to take it times the square root of 3 to get the length of the long side. Okay, so that means if I've got a right triangle that's 30, 60, 90, so 30, 60, 90 right triangle, and the short side is 5, that means the hypotenuse is 10, and the long side is 5 square root 3. The other one we're going to look at is 45, 45, 90, which means it's isosceles. So it's an isosceles right triangle. Because if these are both 45, the base angles converse tells me that these are equal or congruent. Okay? Now, since these are congruent, I'm going to make that be my x. And now, to figure out this last side, we can just do Pythagorean theorem. I'd take x squared plus x squared equals c squared. So x squared plus x squared is 2x squared. If I square root both sides, okay, I would get 2x, x. So I'd have an x on the outside and square root of 2 on the inside, and that's what c would be. So whatever this side is, I'm going to take it times square root of 2 to get the hypotenuse. Okay, and that's the pattern for a 45, 45, 90 triangle. So if we remember these patterns, it makes solving 30, 60, 90 and 45, 45, 90 triangles easier. So here's some examples of how we can use this. Here's the 30, 60, 90 triangle, and they're telling me the hypotenuse is 10. Well, that means that the short side is going to be half that much. And the long leg is going to be the short leg times the square root of 3. Okay, by the way, I knew this is a right triangle because 30 and 60 add up to 90, leaving 90 for this side. Same thing here. Now I've got the long side. Okay, I know it's a long side because it's across from, or it's the long leg because it's across from the bigger angle. Remember back in an earlier chapter we talked about how these angle measurements determine the lengths of the sides across from them. So since this is a smaller angle, this is a smaller side across from it. Now, this is the long side. So whatever this side is, I had to multiply it by the square root of 3 to get 8. So that means if I divide it by this, if I divide this side by the square root of 3, that'll tell me what this side is. So I'm going to take 8 and divide by the square root of 3. And I have to rationalize this because we can't have square roots on the bottom. So I'll multiply the top and bottom by the square root of 3, because when I do that, that's going to cancel out the square root on the bottom. Square root of 3 times the square root of 3 is just 3. And on the top, I've got 8 square root of 3. So that's how long this side is. 8 square root of 3 over 3. So that's the short side. If I want the long side, I just need to double this. Well, this is 8 square roots of 3 over 3. If I double it, I've got 16 square roots of 3 over 3. Okay, and that's how you solve these. Here, this is a 45, 45, 90, because I know I've got two congruent sides, so that means these angles have to be the same. And since they have to add up to 90, they have to be 45. So if this is 3, this is 3, and this would be 3 square root of 2. Here, they gave me the hypotenuse. Whatever this side is, I took it, so let's say x. That means I took x and times it by the square root of 2 to get 5. So if I want to know what x is, I need to divide by the square root of 2. So x is 5 over the square root of 2. I can't have square roots in my denominator, so I have to rationalize. So I get 5 square root of 2 over 2, and that's what x is. 5 square root of 2 over 2, which means this other side would also be 5 square root of 2 over 2. And I know this is 45, 45, 90 because this is 45, that's 90, leaving 45 for this, which makes these sides congruent. Okay, so those are pretty much the main situations that are going to come up. You know, they'll either give you a hypotenuse, or they'll give you the short side, or they'll give you the long side, and it's up to you to find the other two sides given that information. Same with the 45, 45, 90. They'll either give you one of the equal sides or the hypotenuse, and then you use that to solve for the other two sides.